Acha. So you are in third year.
Yes,
Shishir
sir.
Kumar. Shishir Kumar, are you? Am I audible? Can you hear me?
Yeah, good evening, sir.
Yes, yes. Tell me about your
Yeah, sir. I
background.
have
Okay.
just graduated this year and I'm preparing for the gate.
Okay. Okay. Good. Arun. Arun, can you hear me? Okay. Arun, I think Arun cannot hear me. Hema. Hema, can you tell me a bit about your background? Hello. Hema. Okay. Jeevan. Jeevan, can you tell me a bit? Hello.
Yes, sir.
Yeah.
Myself, Jeevan, I'm currently pursuing third year
Okay.
in
So.
electrical.
Okay. Okay. Ved Praveer. Ved, can you tell me about the background that you come from? Uh, okay, I don't think Ved is able to hear me. Okay, so the reason I wanted to know about your background is because because I would be starting something suddenly without teaching anything from without teaching the theory of it. So I just wanted to know whether you are on the same page. So this is the initiative which is started by NPTEL. So we are all PhD students who would be teaching you. I am from Indian Institute of Science, Bangalore, and there would be other people who would be conducting this NPTEL series. So the this is a kind of initial initiative that we are taking. So so we are not giving the like the coaching institute the notes and all. So what we have started is we are trying to solve the previous year questions, some of the questions that have appeared in previous year, and we are asked to interact with you and help you solve the questions. So what I would be doing in this session is I would be showing you the questions that have appeared, and I would ask you to solve the questions, and then if you are having problems we will be discussing. Okay, so that is what my plan is. So, do you have any suggestions? Any suggestions, if you have, you can give me.
सर जो भी टॉपिक से क्वेश्चन हो गए उसके बारे में थोड़ा इंट्रोडक्शन थोड़ा दे देते उसके पहले तो थोड़ा सही है।
मतलब जैसे क्वेश्चंस मतलब क्वेश्चन हम जब
ओवरव्यू
सॉल्व
सर।
करेंगे ना, तो उस उसका रिलेटेड जो बैकग्राउंड चाहिए होगा वो मैं आपको बता सकता हूँ। मतलब फुल फ्लेजेड कोचिंग अभी तो शुरू नहीं किया एनपीटीएल ने, वो ग्रेजुअली हम स्टार्ट करेंगे एक बार पूरा प्रीवियस ईयर सॉल्व हो जाए उसके बाद we'll be thinking about it, but not now, maybe in the coming years we'll be thinking about it. एज ऑफ नाउ हम लोग ने जस्ट प्रीवियस ईयर क्वेश्चंस को फोकस करके उसको सॉल्व करने की कोशिश कर रहे हैं, और ऐसा किया जा रहा है कि people who are specialize in certain fields, they are asked to handle those topics. ठीक है, तो this is how NPTEL is conducting this new initiative. Okay.
Also, sir, we are self-studying students, so not very much good at problem solving. So I want you to specially focus on that and give some of the tips and tricks and anything that you want which is beneficial for us.
Yeah, yeah, sure. Yeah, this kind of sessions will be only problem solving itself. So don't worry about that. So we'll be only doing problems over here. So that won't be a problem for you. I mean, that will be solved. That fear of not able to handle problems and all, that I think will be solved. That you don't need to worry. So
सर
yes.
एक और चीज़ है जैसे जो भी क्वेश्चन है सर उसके बारे में कैसे मतलब एग्जामिनर एक ही क्वेश्चन को घुमा फिरा के पूछता है तो वो भी थोड़ा बता देते किस प्रकार के क्वेश्चन पूछ सकता है तो थोड़ा बेहतर है।
अब वो तो गेट में तो ऐसा बोलना मुश्किल है कि किस प्रकार से एग्जामिनर सोचेगा, दैट इज अ बिट
मतलब सर,
डिफरेंट.
मतलब जो भी क्वेश्चन है तो इस क्वेश्चन से कैसे पूछ सकता है, क्या इसमें दिएगा और क्या पूछेगा सर इस।
Okay, we would see about it as we go along. Don't worry, we'll see about it. So मैं एक काम करता हूँ. Let me open a question and I will be giving you. So I can assume that most of you know control systems, right? आप मतलब ज़्यादा से ज़्यादा लोगों ने control system पढ़ चुके हैं आप लोग, है ना?
Yes, sir.
अच्छा, okay. So what I'm going to do is I will be handling control as of now, as I am asked to handle control systems. So what I'm going to do is I will be giving you questions and I will be giving you some 3 minutes or 5 minutes time to solve it. Okay, 5 minutes is too much. You would be getting typically 3 to 2 minutes in exam hall. So I would be giving about 3 minutes. There is a timer with me. So after 3 minutes is passed, I would ask you to stop and I would ask you the results. If somebody is unable to understand or approach the question, then he or she will ask me, or I mean, we'll discuss actually. Okay. So let us start with the first question. Okay. Okay. So let me share my screen first. Okay. So you can see my screen, right?
Yes, sir.
My screen is visible now?
Yes, sir.
Okay. So let me just give you some question. Okay. So okay. So this is the first question. Okay. So I would be giving you 3 minutes time. Just tell me what would be the answer. So it is 7:12. I would be asking you in 7:15. Everyone has noted down the question. Everyone has a pen and paper with them.
Yes, sir.
Okay.
But C will be the right answer, I think.
Yes.
But C will be the correct answer, I think.
C
Sir,
will be the correct answer. Okay.
D will
Somebody
be
is saying C. Who is saying C?
sir. D is the answer.
Ashwini Kumar is saying D is the answer.
Yes, sir, D.
Okay, D. We have changed. Anyone else? Has anyone else solved it other than Ashwini and Anubhav? Okay, it is already 3 minutes time is up. So I would be discussing. So Ashwini, you can just Tell me, how are you approaching the problem?
Sir, it's a Routh-Horvitz criteria.
Correct, absolutely, absolutely. So for those who are unable to do it, so these are very simple questions. I'm just starting with very simple ones. So I'm assuming that everybody knows Routh or which the Routh array, right? Does everybody know how to construct the Routh array?
Yes, sir.
Can I get a thumbs up from people who already know? Okay. Okay, anyways, so first you have to construct the route array. So you see how to place, so s to the power 3. I mean, it will start, this column would be formed from the highest order of the s. So s cube, s square, s1, s all to the power 0. Now, how to fill in this array? You take the coefficient of this one and then the coefficient of this one. Skip one term, go to the next term, and then keep filling this. Again, k over here and 3 over here. Similar. Now, how would I form this element? Minus 1 divided by this term into multiplication of these two terms minus multiplication of these two terms. So what does the Routh-Hurwitz criteria say? Each and every coefficient should be positive, and all the elements in the first column should be positive. Then only all the poles of the system would be on the right hand side of the S plane. So for this condition to be true, what would happen? This k has to be greater than 0 and this term has to be greater than 0. Now this term can be broken into factors. And that factors is k plus 3 and k minus 1. Okay. So you see, if k is greater than 1, both of this condition is satisfied. This will be also greater than 1, this will also be greater than 0, this will also be positive. So the correct answer would be D. Okay. So has everyone got it? Has everyone got the answer?
सर
Yes.
अश्विनी को म्यूट कर देते सर, आवाज आ रहा है बस।
हाँ.
अश्विनी को म्यूट कर देते आप सर, नॉइजी आ रहा है सर बैकग्राउंड।
अश्विनी को, अच्छा. Okay. Okay, I have muted him. Okay, no problem. Okay, let us go for the next problem. Okay, we will be going for the next problem.
सर फिर से वो क्वेश्चन दिखाते हैं सर, नहीं स्क्रीनशॉट लेना था।
पुराना वाला क्वेश्चन.
यस सर, प्रीवियस।
देख पा रहे हो?
यस सर, यस सर।
Okay, so did you understand how to approach this sum? This is a very simple sum. I mean, this would hardly take you 1 or 2 minutes to do. Have you understood, Abhishek Sharma?
यस।
Okay. Okay, then let us go for the next sum. Okay, I will be going for the next sum. So let us close this. Okay. Okay, so the next sum is, so a system has been given to you. So this e to the power minus s, do you know what this is called? You people know what e to the power minus s is called? Have you heard of the term transport delay?
Transportation lag.
Yeah, transport delay. Yeah.
Yes, sir.
Yeah, okay. So you have been given a unity feedback system, okay? And you need to find k for which the phase margin of the system will be 30 degree, okay? So I would again give you 3 minutes, okay? You try to solve it and then tell me what would be the answer. Don't be afraid to, do sums. Try to practice as much as you can. And I would suggest everyone to take these sessions as a practice sessions, because we are not teaching the theory part and all. It is, you cannot wholly depend on us. You can study on your own, and people who are involved with this initiative, they can make you practice all these questions from the previous year. And you, other than previous year, you also need to practice other questions from other sources, maybe some material, some books. There are several books available. You can just take, you can try it out. but you need to practice as much as you can if you want a good score in gate. Okay, so try to try this sum and tell me what you think would be the answer. I hope everybody knows what phase margin, gain margin, and all these things are. Everybody knows about it, gain margin, phase margin, and everything.
Yes, sir.
Okay. So 5 minutes time, 5 minutes to 3 minutes time, 23, 7:23. I will be asking you. I'm giving you 3 minutes time to solve the question.
Sir, 0.366.
0.366. Who is that saying 0.366? Let me just see. Who is that? Ashwini, is that you? Who is it?
Sir, Anubhav.
Anubhav, okay. 0.366 you are saying, right?
Yes, sir.
Okay. Who else? Who else has done it? Who else has tried doing it? Ashwini, have you tried?
Sir, I don't know the procedure for this question.
Excuse me,
You
sir.
okay? Okay, we will discuss it. And
Sir,
anybody else who has found the answer for it?
sir,
Yes. Who else?
sir, sir, there was a calculation mistake. The answer is 0.21. Value of
0.21. You are saying.
yes, sir.
Okay, 0.21. Who else? Anybody else who has done it? Navkirti, you have done it. Jivan, Shishir,
No,
anybody?
sir.
You are trying or you have just left?
I think I'm doing wrong.
Okay, okay, no problem, no problem. Okay, so time is up actually. It is already 7:23. So let us discuss again. So how are you going to approach it? Anubhav have done it, right? Anubhav, or who was that? Anubhav, right?
Yes, sir.
Yeah, Anubhav Tripathi. How are you approaching the question?
Sir, I use the formula the phase margin is equal to 180-degree plus angle of GH.
Yes.
So we just expand e to the power minus s into 1 minus s. Then
Do
we
you
find
need
the
that?
transfer function. We find the
But
angle.
do we
Then
need that over here to
do the
expand
rest
e to
of the
the power minus
calculation.
s?
Sorry, sir.
Do we need that? Why do you need to expand e to the power minus s?
Sir, I have studied that while calculating phase, we do that in solving problems.
What do you need to find out to find the phase margin? The first thing that you need to find out.
We need to find the angle of transfer function,
At what frequency?
like gain crossover frequency.
Correct. So what is gain crossover frequency?
Magnitude, sir, magnitude becomes 1, yes, sir.
Correct. So what is the magnitude contributed by this e to the power minus
Nothing,
s term?
nothing. We ignore that in contributing magnitude.
Why do you ignore it?
Sorry, sir, I don't have explanation, but in solving problems, while calculating for magnitude, we ignore it, but for angle, we take it.
Acha. So e to the power minus, so you replace s with j omega. Okay.
Yes, sir, yes, sir.
So if you replace s with j omega, e to the power minus j omega, what can we write e to the power minus j omega?
Shows angle in radian.
So can we use De Moivre's theorem and can we write sin theta plus cos theta kind of stuff? Cos theta plus j
Yes,
sin
sir.
theta. We can write that.
So its answer is root 3.
Root 3. Root 3. Maybe I do not know. Let's see. We will see as we go along. Okay. I have not memorized the answer. It would be something close to that. 1 point something would be the answer. Exact answer I've forgotten. So as I was saying, so why do you ignore? So that is what I was explaining. So see, e to the power j omega is over here. Okay. So what is the magnitude of this? Its magnitude is 1, right? Right, Anubhav?
Yes,
So
sir,
get
yes, sir, I got that.
e to the power minus s magnitude is 1, so there is no need to think about this. So you are concerned only with k and this s over here, the k by omega. Okay, so see, so I have replaced s with j omega. So this is the thing that you get. So if we look at the magnitude of this at gain crossover frequency, so our objective is to find the gain crossover frequency first. At first, we need to find the gain crossover frequency. Then only we can find the angle contributed by this transfer function at gain crossover frequency. So let us find the gain crossover frequency first. Okay, so we put magnitude of this must be equal to 1. Okay, so if we do that, so what do you get? This term is contributing magnitude unity. So k divided by omega jc is the thing that we should be concerned about. So the gain crossover frequency becomes equal to k
Excuse me, sir.
radians. Yes, yes.
Ashwini, can you please mute yourself? We are not able to understand what sir is saying.
Okay. Do you want me to repeat, Kirti?
Yes, sir.
Acha, okay. So did you understand the fact that that e to the power minus s, this term is contributing unity magnitude?
Yes, sir.
Now,
No, sir, I
Kirti,
couldn't understand anything because of the noise.
okay. So first, this transfer function that we have, let us replace that with j omega. Okay, replace s with j omega. We can do that.
Yes, sir.
Okay. So once we do that, so what does this transfer function becomes? It becomes like this, right?
Yes, sir.
So now you see e to the power minus j omega, this term, is it contributing any magnitude to this term? E to the
So,
power minus j omega, this term, only this portion I'm talking about.
no, sir.
Why no?
The K is contributing towards magnitude.
What is the magnitude of e to the power j omega? Can we write e to the power minus j omega as cos of j omega minus j sin omega? Can we write like that?
Yes, sir.
Okay, so what is the magnitude of that term? That magnitude is unity, right? There is no, there is no magnitude. It only affects that phase of the system, right? This part.
Okay, sir.
Did you understand why it is contributing to phase only? It is not contributing to magnitude at all.
No, sir.
So this e to the power minus j omega, this term, this transport delay term, if you find, I mean, if you can expand that using De Moivre's theorem, you will find that it is contributing only to the phase. It is not contributing to magnitude at all. The magnitude of e to the power minus j omega is unity,
Okay, sir.
right? Are you getting why this is happening? Because it, see, so e to the power alpha minus j omega, if there was some real term over here, it would have contributed to some magnitude to this k divided by j omega term. But there is no real part. It is only minus of j omega. This is only the phase of the system.
Okay, sir. As transportation delay only delays the signal, not do
Yeah,
anything
you
with
can think of
magnitude.
like that. Yeah, so the magnitude of this term, this portion is unity. So if you take magnitude of this, what are we going to get? K divided by omega only, right? This term becomes unity, right, Kirti?
Yes, sir.
So why are we doing all these things? We need to find the gain crossover frequency.
Yes, sir.
We need to find the cross frequency at which this the magnitude of this becomes unity, right? So if you want
Yes,
to
sir.
do that, so let us see. So if I put magnitude of this equal to 1, that means K divided by omega jc equal to 1. So omega jc becomes equal to K radians, right? You understood up to this, Kirti?
Yes, sir.
Okay. So now phase margin is said to be 30 degree, right? 30 degree is pi by 6. So pi by 6 must be equal to pi plus the angle contributed by this transfer function at gain crossover frequency. The formula that I've written over here. This is the definition of phase margin. 180 degree plus the angle contributed by this at gain crossover frequency. So we now have found out the gain crossover frequency. Now we need to find out the angle at gain crossover frequency. Okay.
Yes, sir.
So now while I am talking about angle, now this omega gc will come into picture. Okay, because this is contributing only to the angle. Okay, you getting my point?
Yes, sir.
Okay, so you see, so pi is there. 180, this comes from 180 degree that I've written over here. Pi plus this thing. So this pi plus the angle. What is the angle? Because of this pole, it is going to get a minus 90 degree angle. So I have written minus pi by 2. And for this term, it is going to get a phase of omega. And I'm talking about gain crossover frequency. So omega gc, right?
Yes, sir.
So from here, as we already know, omega gc equal to k radians, that we have already found out. So replace omega gc by k. Okay, this is what I have done over here. Okay. So if you solve that, pi by 6 is equal to pi minus k minus pi by 2. From here you can find k equal to 1.047. So none of your answers were correct. Getting my point?
Yes, sir.
Okay.
Sir,
Oh. Yes, Kirti, tell me.
can't we do it by expanding e to the power minus s and ignoring
The-
higher order terms?
Yeah, see, if you are expanding it, then you are basically neglecting the higher order terms. You are truncating a lot of information. Okay, so
Okay, sir.
that method is not, I mean, that method is an approximate method, which would have been a problem if we couldn't have found this, if there was a problem with this. Here the sum is quite simple. In GATE, the questions are structured in such a fashion so that you can calculate it, in a faster fashion. So because there would be other longer questions also. So in this case, there is no need of doing that. But in certain questions, when the system would be a bit more complex, then and we cannot find the angle in such a easy fashion, then you need to expand it. But in this question, there was no need to it. And see how much error that you are going to have. So here, at max, you are going to have a range of 1 to 1.1 or 2. And your 0.22 is too less, so it will be your sum would be wrong. So it is better where there is no need of expansion, do not do expansion. When there is a need for doing expansion, maybe in the next class I will show us some where you will need expansion. There is no other way out. In that case you have to do it. There is no other way out. But in this case it is easy, because see, if there was a pole over here, okay, not pole at 0, some pole over here. So in that case there would be tan inverse or something. There would not be pi by 2. In that case you will face difficulty. Okay, in that case, because tan inverse and omega gc, it becomes a transcendental equation. In that case, you cannot solve it in this easy fashion. Only because there is a pole at 0, it is easy for you to write ki it is contributing pi by 2 angle. But if there was pole at some other place other than 0, it would have been difficult for you to calculate, because it will be tan inverse of something and it will be omega. So it becomes a transcendental equation. You cannot solve it by hand. In that case, you need to 1 minus s, you have to substitute, and you have to expand it in this fashion, and then you have to approximate. But in this case, there is no need.
For phase margin formula, we use open loop So, and we find the angle of open loop function or closed loop function.
Open loop, open loop.
And for gain margin, uh,
Gain margin also we go for open loop. Not we are not talk we don't talk about closed loop, because see, gain margin and phase margin are required, are information that is required for you to, to make this closed loop system. Whether how to, do, whether we need a compensator, whether we need a compensator over here or not, to identify whether the system is stable or not. That information you need to, to form a closed loop. So these are the information that you need beforehand, before you close the loop. So we need to talk about the phase margin and gain margin of the open loop system, not the closed loop system. You do the analysis first, and then we go, okay, so the system is stable if I do closed loop also, and then we can design appropriate compensator or a closed loop system. So these are always we are always calculating phase margin and gain margin for open loop systems. I mean, for the open loop transfer function, not the closed loop transfer function. Okay, is the procedure clear? Are you and Anubhav, are you understanding when we
yes,
need
sir,
that?
yes, sir.
Yeah, when we need that expansion, when we don't need. So
Yes, yes.
when there is a pole at zero, there is no need for you to do the expansion. If there was some other term, say one minus s or one plus s or s plus two or something like that, then you need that expansion. So try to avoid all these expansions and all as long as possible. Okay, so none of your answers were correct this time. Okay, so let us go for the next sum. Okay, I will be talking about the next sum. What is this? Which folder was it? Okay, this one. Question number 30, right? Okay. Okay. Okay, there is a simple sum again. So there is a differential equation given to you with initial condition 0, and we need to find out the impulse response of the system. You know impulse response. You know what a impulse response means? Hello. Hello. You,
Please show the
Kirti.
question.
I will show. I will show. You know what impulse response is? How to find an impulse
Yes, sir,
response?
yes, sir.
Yes, sir.
Yes, sir.
Okay.
That is the
Okay.
Laplace transform of the output response and input response.
हाँ हाँ, अब तो आप ये वाला ये डिफरेंशियल इक्वेशन दिया हुआ है आपको, इम्पल्स रेस्पॉन्स निकालना है। तो मैं फिर से आपको 3 मिनट टाइम दे रहा हूँ। इट इज 7:35, 7:38 आई वुड बी आस्किंग यू टू स्टॉप।
Let's see.
Maybe I do not know. We'll see. Okay. Maybe see. I do not know. Let's see. Somebody is saying D.
Sir, B, sorry, sir.
What? What did you say? I didn't get.
Sorry?
What did you say? Which option are you saying?
Sir, B.
B. Okay. Okay. 1 more minute left. is asking to join. What is this?
Sir, it's B. Second one.
Second one. Okay, two people are saying B. One guy said C. Okay. Let's see. So I think time is up. So let us go ahead with the sum. So these are very simple sums. So you can just mentally do it. S square plus 7s plus 10 into ys becomes 4s
ऑप्शन
plus
बी
5.
से
Okay. So just take Laplace transform on both sides. So what do you get? S square from here. Then 7s plus 10 into ys becomes equal to 4 plus 5s into xs. So impulse response means ys by xs, right? So 5s plus 4 divided by this thing. So you not divide it into this partial fractions like this. So if you take now, you need to find the inverse, Laplace inverse of this expression. So what do you get? Minus of 2 e to the power minus 2t plus 7 e to the power minus 5t. Right? So B was the correct option. So there were two people who said it. I think Anubhav Tripathi said it, right?
Yes, sir.
And okay, so B was the correct answer. Good. Okay, so these are quite simple. So Kirti, did you get it? Did you understand?
सर मैं कंफ्यूज हो गया सर कि यहाँ पर इम्पल्स रिस्पांस पूछ रहा है तो
हाँ हाँ.
आर एस इज इक्वल टू हम लोग 1 लेके चले सर क्योंकि इम्पल्स है तो
क्यों क्यों कहाँ पे कौन सा वन? लेकिन हाँ, वो एक्सेस को
क्योंकि
वन कर
इनपुट
सकते हो. इनपुट एक्स है ना,
ये सर
आउटपुट वाई है.
तो
तो
मुझे
इन
यहाँ पर तो इनपुट में यूनिट स्टेप दिया जा रहा है
कहाँ पे यूनिट स्टेप दिया गया है? यूटी बोल रहा है कि यूनिट स्टेप फंक्शन है. ये यूटी इसलिए दिया
ओ
जाता है ताकि ये बोला जाता है कि दिस आउटपुट जो है ये एग्जिस्ट फ्रॉम टी इक्वल टू जीरो. क्योंकि उसका पहले का हमको पता नहीं है, यहाँ पे पता है क्योंकि एक्स वाई टी जीरो कर दिया गया है. तो इसका आउटपुट तब जीरो था क्योंकि कोई इनपुट था ही नहीं उससे पहले. इनिशियल कंडीशन भी जीरो, इनपुट भी जीरो, तो आउटपुट भी इसका जीरो होगा. ठीक है, तो उसके
अगर
बाद
रैम
ही
पूछता तो सर अगर रैम रिस्पॉन्स पूछता तो हम लोग ये एस स्क्वायर से कर देते 1/s² से मल्टीप्लाई
बताओ
कर
रैम
देते उसके
अगर पूछता तो क्या करते बताओ. सबसे
रैम
जल्दी
पूछता
क्या
तो
होता तुम अगर
1/x² से मल्टीप्लाई कर देंगे सर वाई ऑफ एक्स जो फंक्शन आएगा सर
और कोई तरीका हो सकता है? और कोई तरीका?
मुझे तो नहीं लगता
Anybody else in the class? He is asking, say, if you are given impulse response, can we find ramp response from it? Any quick answers from the question posed by Abhishek Sharma?
Yes, cot x is equal to 1 upon x in the Laplace.
वो तो भाई बहुत लंबा हो जाएगा ना भाई. दैट वो करने बैठोगे तो बहुत टाइम लगेगा तुमको. जल्दी कैसे करोगे? हाउ टू डू इट फास्ट? जैसे कि do you know of any other method? Anybody in the class? Anybody? So if impulse response is given, can you find ramp response or step response? Forget about ramp, find step response.
We will integrate 2 times.
Very good, very good, wonderful. Yeah. So that is the answer he wanted. Yeah, right. He is right. Venkatesh. Yeah. So in LTI system, there is a property. So if you know the response of the system to a given input, the differentiation of that input would be the differentiation of the output. The integration of the input would be the integration of the output. So integration of impulse response would be what? Step response. Integration of step response would be what? Ramp. So you integrate twice, you will get it. However, there may be some problems because integration comes with a constant and all. But that is a easy way to sort out your options. If you have 4 options, you can easily do that in mind. You integrate twice and then find, okay, this is closest to the option, you can mark it. Okay, so that is a very good question that was asked by Abhishek.
इंटीग्रेट या डिफरेंशिएट से द आउटपुट डिफरेंशिएट
इम्पल्स रेस्पॉन्स को इंटीग्रेट करोगे तो क्या होगा?
Unit.
response.
यूनिट
Step.
यूनिट स्टेप, राइट? अब यूनिट स्टेप को इंटीग्रेट करोगे तो क्या होगा?
Ramp.
रैम्प
राइट? तो अगर से मैं ये बोल रहा था कि इफ यू नो कि if you know the output to a given input, then the integration of the input would be the integration of the output. समझ रहे हो ना हम क्या बोल रहे हैं? मैं देखो, जैसे कि मैं बोल रहा हूं कि मुझे पता है कि दिस इज द इम्पल्स रिस्पॉन्स, ठीक है? दिस इज द आउटपुट टू अ
यस
इम्पल्स रिस्पॉन्स, टू अ इम्पल्स इनपुट. अब अगर मैं स्टेप रेस्पॉन्स निकालना चाहूं तो लेट अस इंटीग्रेट द इम्पल्स, विल गेट स्टेप, and we'll integrate this output with respect to t to find the output to a unit step input. अगर यूनिट स्टेप को फिर से हम इंटीग्रेट करें तो क्या आएगा? रैंप आएगा. तो वो जो स्टेप रिस्पॉन्स आया उसको फिर से इंटीग्रेट करो तो वो तुमको रैंप में इनपुट देगा. मतलब अगर तुम इनपुट रैंप दे रहे हो तो उसका आउटपुट क्या होगा वो तुमको दिख जाएगा.
यस सर। और दूसरे वे में हम लोग आर ऑफ एक्स इज इक्वल टू 1/x² से
हाँ,
मल्टीप्लाई
वो एक्स
करके
स्क्वायर,
फिर
हाँ बिल्कुल बिल्कुल, वो करने जाओगे तो बहुत टाइम लगेगा ना तुमको. ये देखो, यहाँ पे एक्स स्क्वायर आ जाएगा,
यस
ऊपर एक्स स्क्वायर आएगा, तुम ऊपर फिर क्यूब आ गया, अब तुम इसको पार्शियली डिफर ये पार्शियल फ्रैक्शन में ब्रेक करो तो उसमें बहुत टाइम जाएगा. अगर तुमको ये पता है तो वो बहुत जल्दी हो जाएगा.
यस
तो आज के लिए लास्ट क्वेश्चन, एक और क्वेश्चन मैं दूंगा, उसके बाद क्लास खत्म कर देंगे. ये लास्ट क्वेश्चन है, ठीक है ना? रुको, ये ओके. अच्छा, अच्छा, ठीक है. तो ये सिग्नल फ्लो ग्राफ दिया हुआ है. ओके, देर आर टू इनपुट्स u1 एंड u2 एंड यू नीड टू फाइंड द ट्रांसफर फंक्शन ys डिवाइडेड बाय u1s. चार ऑप्शंस दिए गए हैं और तुम्हें बताना है कौन सा सही ऑप्शन है. ठीक है, अगेन आई एम गिविंग यू 3 मिनट्स. ओके, 3 मिनट्स टाइम के बाद मैं फिर से तुमको बताऊंगा. सो इट इज 7:47 नाउ, सो अप टू 7:48. So let us 7:51 would be asking you the answers.
Sir, I think A is the correct answer.
कौन बोल रहा है ये?
Anubhav sir.
अनुभव. ओके, अनुभव बोल रहा है ये होगा. और कोई?
Sir, A is the correct answer.
ओके, two people are saying A.
Jignesh.
यस ऑप्शन एस
Okay, three people are saying. Okay, time is up. So let's see what would be the answer. Okay. So these are all simple questions. There was only one a bit of a tricky question, that was the transport delay part. बाकी सारे क्वेश्चंस तो काफ़ी सिंपल थे. तो ये वाला भी काफ़ी सिंपल है. ये देखो, द फॉरवर्ड गेन पाथ अगर तुम देखोगे इसमें, तो देखो पहले क्या है कि देयर आर टू इनपुट्स. ओके, सो बट वी आर नॉट कंसर्न विद U2 बिकॉज इट्स द LTI सिस्टम. सो लेट अस फॉरगेट अबाउट U2, क्योंकि LTI सिस्टम में क्या होता है कि if you give a input U1 and you get and give a input U2, so the output Y would be the summation of the output of U1 and summation of output of U2. So we are not concerned with U2 as of now. So let us set U2 equal to 0. So we have only this path. We have only U1. Okay. So this path has to be rubbed off. So we wipe off this part and we are left only with this signal flow graph. Okay. So you have only one forward gain path over here. और कोई फॉरवर्ड गेन पाथ तो है नहीं, सीधा एक ही लाइन जा रहा है यहाँ से इनपुट से आउटपुट तक. सो इस सारे को मल्टीप्लाई कर दो, तो 1/L इंटू 1/S इंटू K1 इंटू 1/J इंटू 1/S. सो ये आएगा G1 इक्वल टू K डिवाइड बाई L JS स्क्वायर. ओके, अब लूप देखते हैं कि हाउ मेनी लूप्स आर देयर. सो वी कैन फाइंड दैट देयर इज वन लूप ओवर हियर. सो 1/L1 इंटू 1/S इंटू माइनस ऑफ R. सो लूप 1 का गेन हुआ माइनस ऑफ R डिवाइड बाई SL. लूप 2, ये बड़ा वाला लूप भी दिख रहा है आपको, तो दैट इज माइनस ऑफ K2 इंटू 1/L1 इंटू 1/S इंटू K इंटू 1/J इंटू 1/S. सो L2 का गेन आ जाएगा ये K1 K2 डिवाइड बाई LJS स्क्वायर. ठीक है. उसके बाद लेट अस डिफाइन टू मोर टर्म्स. ओके, सो एक है डेल्टा. डेल्टा ऐसा टर्म है जिसमें 1 माइनस सम ऑफ इंडिविजुअल लूप गेन्स. जितने भी सारे लूप्स है L1 L2 जितना भी सारे लूप्स है उस सारे का गेन तुमको सम करना है. और यहाँ पे क्या है, सम ऑफ ऑल पॉसिबल नॉन टचिंग लूप्स, मतलब जितने टच नहीं कर रहा है एक दूसरे को. से यहाँ पे एक और अगर लूप होता जो ये दोनों टच नहीं कर रहा था, तो ये दोनों को मल्टीप्लाई करके तुमको यहाँ पे सम करना था. मगर यहाँ पे ऐसा कुछ है नहीं. 3 नॉन टचिंग लूप अगर ऐसा रहता कि यहाँ पे एक सेल्फ लूप है, यहाँ पे एक और लूप है, तो ये तीनों लूप एक साथ टच नहीं कर रहा है, तो ये सम ऑफ ऑल पॉसिबल गेन्स ऑफ 3 नॉन टचिंग लूप यहाँ पे तुमको सम करना होता. मगर दिस टू आर इक्वल टू 0 इन दिस केस. सो व्हाट वी आर लेफ्ट विथ इज 1 माइनस L1 माइनस L2. सिमिलरली एक और टर्म हम डिफाइन कर रहे हैं डेल्टा 1, जो कि इट इज अ पार्ट ऑफ डेल्टा विच इज नॉट टचिंग द पाथ फॉरवर्ड पाथ G1. मतलब यहाँ पे जितने भी टर्म्स है जो कि G1 के साथ जुड़ा हुआ है, मतलब जो कि G1 को टच कर रहा है, जैसे कि ये देखो, ये वाला लूप जो है ये G1 को टच कर लिया, ये वाला लूप जो है वो भी G1 को टच कर लिया, तो यहाँ पे सारे जो टर्म्स है ये सारे टर्म्स 0 हो जाएगा. सो वी आर लेफ्ट विद डेल्टा 1 इक्वल टू 1. ओके, अब ये फॉर्मूला तुमको याद रखना है. जस्ट अ मिनट. सो यू आर ओनली लेफ्ट विथ ये फॉर्मूला तुमको याद रखना है. ये क्या होता है कि G1 इंटू डेल्टा 1, अगर दूसरा कोई फॉरवर्ड पाथ रहता तो G2 इंटू डेल्टा 2 ऐसा रहता, मगर यहाँ पे दूसरा कोई फॉरवर्ड पाथ है नहीं और नीचे डेल्टा वाला टर्म है. सो यू जस्ट सब्स्टिट्यूट दिस पार्ट, सो यू विल गेट A as the answer. So A was the correct option. So most of the people have done it correct. So not an issue.
Sir, one question, sir.
Yeah.
When we take कौन से केस में हम मुझे मालूम चलेगा कि दोनों इनपुट को लेके चलना है सर? यहाँ पर तो मैंने एक इनपुट को 0 कंसीडर करके चला,
हाँ.
लेकिन मुझे क्वेश्चन को देखते हुए मुझे मालूम कैसे चलेगा कि दोनों इनपुट को लेके चलना है सर?
तुम्हें ट्रांसफर फंक्शन निकालने के लिए किस चीज का ट्रांसफर फंक्शन निकालने के लिए कहा गया है? U1 का, U2 का तो नहीं बोला है तुमको.
No, sir.
तो U2 अगर तुमको मतलब U2 इज नॉट योर कंसर्न, देन सेट दैट U2 इक्वल टू 0, क्योंकि ये आप कर पा रहे हो क्योंकि ये LTI सिस्टम है और गेट के सिलेबस में सिर्फ LTI सिस्टम्स ही है. तो जब तुमको
तो
बोला,
ऐसे भी तो कर सकते हैं सर कि पहले जब इनपुट सिग्नल इनपुट ले लिए E1, उसके लिए आउटपुट निकाल लिए, फिर U2 को लेते हुए फिर आउटपुट निकाले, फिर दोनों का सम कर दिए, वैसे भी तो हो सकते हैं.
नहीं U2, मगर U2 तो चाहिए नहीं ना तुमको ट्रांसफर फंक्शन बोला गया है YS by U1S, तुमको Y by U2 नहीं पूछा है ना.
तो ऐसे केस में दूसरे इनपुट सिग्नल को 0 कंसीडर करके चलना है.
राइट. दूसरे इनपुट को तुमको 0 सेट कर देना है. उसके बाद तुमको सिर्फ U1 के बारे में सोचना है, बिकॉज यू आर आस्क्ड टू फाइंड YS by U1S.
Yes.
right? So you don't, there's no need for you to get bothered about U2 and all. ठीक है? So this
Yes.
question has been answered by most of the people. So today we had only one tricky question, right? So none of the questions are very hard, I hope.
सर अभी तक इस वीक में सबसे इंटरेक्टिव सेशन यही मुझे अच्छा लगा सर, क्योंकि पीछे जितने भी सेशन हुए उसमें क्वेश्चन को मुझे मतलब हम लोग को मिलता ही नहीं था टाइम सॉल्व करने के, तो ये मतलब बहुत ही अच्छा सेशन रहा सर मेरे लिए।
अच्छा,
थैंक यू।
थैंक यू भाई, थैंक यू। बात ये है कि ये ऐसा कोई यहाँ पे कोई ये नहीं दिया गया है, कोई क्या कहते हैं इसको, कोई रूल या फिर कुछ इनिशिएटिव के लिए कुछ रूल सेट किया नहीं है हमारे यहाँ पे। सो एवरीबॉडी इज टीचिंग ऑन देयर ओन, ओके। तो मैंने सोचा कि थोड़ा इंटरेक्टिव रखते हैं ताकि तुम लोगों को चांस मिले, क्योंकि देखो ये सेशन का कोई मतलब ही नहीं है अगर तुम प्रैक्टिस नहीं करते हो, बेकार सेशन होगा फिर, क्योंकि यू
यस
हैव
सर।
टू रीड थ्योरी ऑन योर ओन, क्योंकि हम लोग पढ़ा नहीं रहे थ्योरी। फ्यूचर में हम लोग शायद ये इनिशिएटिव शुरू करेंगे, मगर अभी हम लोगों के लिए पॉसिबल नहीं है, बिकॉज इट विल टेक अ लॉन्ग टाइम इफ यू स्टार्ट कवरिंग थ्योरी एंड ऑल। तो तुमको वो अपने से कवर करना होगा। तो मैं ये सजेस्ट करूंगा कि दिस सेशंस यू कीप एज अ प्रैक्टिस सेशन, कि अच्छा चलो थोड़ा थोड़ा माइंड को रेस्ट कर लेते हैं, थोड़ा प्रैक्टिस करके देखते हैं। और मैं गेट के लिए सजेस्ट करूंगा कि जितना हो सके क्वेश्चन सॉल्व कीजिए, ठीक है। गेट ऐसा है कि आप कितना भी थ्योरी पढ़ लीजिए ना, वो नहीं होने वाला। आप अगर आप प्रैक्टिस नहीं कर रहे हो, सिर्फ थ्योरी पढ़ रहे हो बुक से, किताब से, आप नॉलेजेबल बहुत बन जाओगे, मगर गेट निकालना थोड़ा मुश्किल हो जाएगा आपके लिए। तो मैं ये चाहूँगा, जैसे कि अनुभव ने भी एक जो क्वेश्चन सॉल्व किया था, उस बोल रहा था कि हमको पता नहीं है कि e⁻j ओमेगा क्यों यूनिटी मैग्नीट्यूड होता है, मगर कर दिया। तो दिस एक्सपीरियंस ऑल्सो हेल्प्स यू कि भाई ये सम को ऐसे ही करना है, ठीक है। चाहे वो ये धीरे धीरे सीखोगे, विद टाइम यू विल गेट यूज टू इट, मगर दिस आर वेरी इंपॉर्टेंट स्टफ। अनुभव, अनुभव,
यस सर, यस सर,
ये e⁻j ओमेगा क्यू यूनिटी दे रहा है, समझ में आ रहा है ना तुमको?
यस सर, यस सर।
तो बताओ फिर हमको।
उसका मैग्नीट्यूड जो होता है अंडर रूट कॉस स्क्वायर थीटा प्लस साइन स्क्वायर थीटा।
एब्सोल्युटली, वेरी गुड, यस, गुड। तो इसीलिए हम उसको यूनिटी कंसिडर करते हैं, ठीक है। हाँ
Sir,
अश्विनी, हाँ हाँ।
one the next class. Can you sir tell me the in the next class what topics should we prepare?
ऐसा तो हमको देखो, हम लोग आई एम टेलिंग यू द प्रोसेस कि कैसे ये लोग कंडक्ट कर रहे हैं, ठीक है ना। सो वी आर गिवन क्वेश्चंस बिफोर, 1 week बिफोर, व्हाट क्वेश्चंस वी हैव टू डिस्कस। वी प्रिपेयर अ पीपीटी। ये सारे क्वेश्चन जो है एनपीटीएल पोर्टल में अपलोड भी होगा, ठीक है। जैसे कि मैंने लाइव सेशन लिया आज, तो मैंने इसका रिकॉर्डिंग भी, कुछ प्री रिकॉर्डिंग भी कर लिया है। तो ये सारे शायद एनपीटीएल पोर्टल में, ये सारे जितने भी मैंने क्वेश्चंस आज डिस्कस किए, ये सारे अपलोड होगा एनपीटीएल का पोर्टल में, ठीक है। तो वहां से भी आप देख सकते हो। तो वो शायद बाद में होगा, कब होगा ये हमको पता है नहीं, मगर ये शायद अपलोड होगा, ये वाला जो भी वीडियो है वो अपलोड होगा। तो हम लोगों को पहले से पता नहीं होता था वैसे कि कौन सा क्वेश्चन सॉल्व करना है, ठीक है। तो okay, Nitya Kumar is saying me, asking me to speak in English. I'm speaking English. So what I'm saying is that they are, I mean, what we are asked to do is, we are given a few questions 1 week before the session is conducted, and we are asked, we prepare a solution for that, so that is uploaded in the NPTEL portal. That is different from this. I mean, that is different from the live session. So in live session you can interact, you can ask me questions, you can tell your difficulties. Don't be ashamed of, you don't think like I'm asking a foolish question. Don't think like that kind of stuff must not come to your mind, because if you don't ask this foolish question, it may appear foolish to you, but it may not be such a foolish question. So ask whatever question you have in your mind, you can ask, okay. So I planned this session in such a fashion so that you get some time to practice a bit, because then it will be helpful for you. So
हेलो सर।
yes, yes, yes.
सर डाउट्स है।
हाँ बताओ बताओ।
अच्छा सर, ये जो गेट का जो सिलेबस है, मैंने सेकेंड और थर्ड ईयर के अंडर में ही आता है क्या?
सेकेंड, थर्ड, फोर्थ सब आएगा भाई।
सब फोर्थ ईयर में आएगा क्या सिलेबस में?
क्या आई डोंट नो व्हाट सिलेबस यू हैव इन फोर्थ ईयर।
सेकंड थर्ड ईयर का
No, sir, it's under the third year. All the subjects are considered only the third years.
अप टू
Okay.
थर्ड ईयर तक ही तो है हाँ
Yes,
Okay.
sir.
So I do not know what is the course that is taught in your university in third year.
All the subject mainly covered in up to the third year.
Okay. So
अप टू द
apparent.
थर्ड ईयर
हाँ हाँ.
सर मैंने अप टू थर्ड ईयर तक ही आएगा क्या वो सिलेबस ऐसे गेट एग्जाम का?
सो फॉर सिलेबस तुम सिलेबस देख लो, गेट सिलेबस, ठीक है, एक बार
सर
देख लो.
गेट सिलेबस तो देखे अप टू थर्ड ईयर तक का है पूरा,
बस वो
फोर्थ ईयर का
थर्ड ईयर.
कुछ नहीं है।
Power electronic power system is considered only in third year. After that, all the will be done in the second year, like the
Okay.
electric circuits theory, analog circuits, and digital circuits. And
Okay. Okay.
Actually, sir, I am giving this gate exam for the first time. I am in the third year class. That's why I'm asking.
वो मतलब तुम सिलेबस देखो और थर्ड ईयर, क्योंकि हर एक यूनिवर्सिटी का सिलेबस अलग अलग होता है, ठीक है.
हाँ हाँ
सो ईच एंड एवरी यूनिवर्सिटी हैज अ डिफरेंट सिलेबस ऑफ देयर ओन. सो यू नो, सो यू कैन नॉट से लाइक दैट कि थर्ड ईयर और फोर्थ ईयर. यू हैव टू गो थ्रू, यू लुक एट द सिलेबस, ट्राई टू कंप्लीट द सिलेबस.
Thank you, sir.
Sir, I want to say something.
या Navkriti, tell me.
Sir, instead of first question, I know that I can solve all the three questions, but whenever I see a question in any kind of an exam and there is a time limit, I feel blank. I can think nothing when I just see a question. Even I forgot the Mason-Gaines formula. I forgot now how to form Roth array, which is quite basic, and I know I can do it. So, how to overcome this? And this has very negatively impacted all the exams that I have been appeared until now.
So there are several ways to do it. So you have to identify what exactly is your problem. So if time pressure is your problem, then you can practice test series. Okay, you can join some test series and you can practice that. That would help you. And don't be afraid of the results, because that is not gate exam. Okay, so you have to be very much so in test series there are several kind of tests. You will see there will subject test, part test, then full syllabus test, then before gate there will be mock test. So if you are if you can somehow complete all the tests, somehow you can manage to. So it is very difficult to appear for all the tests. You have to plan accordingly, but at least 3 or 4 gate mock test has to be given before before you appear for the real gate exam. Okay, so that is very important.
Yes, sir, I purchased the Made Easy online test series, but I was facing the same issue that I just faced now. Even in test series, I feel blank. I can't do anything. Only that thing goes in my mind is time, and can't think anything.
Now that happens because of lack of practice. So what you do is, so how are you practicing? Tell me, how are you, I mean, how do you prepare subjects?
I prepare subjects. First, I read the theory and then their questions, and this is
Theory, from
how.
where are you reading, and how are you reading theory?
Sir, uh, before this year, I was self-studying, so mostly the NPTEL and some coaching notes from the online that I got. And this year, I got my friends' coaching notes, all of them. So I'm
Okay.
preparing from those. Even so, for example, machines. I think machine as the my strongest subject, and when solving question, I can solve by taking quite much time. But when I appeared in gate and tried to solve even the simplest question, I even forgot the formula of efficiency, and this happens every time, and I'm not able to figure out it just how to deal with it.
So the way that I know how to deal with is to appear for test. So you once you start appearing for more and more tests, okay. So after a certain period of time, you would feel very comfortable with test. You need not bother about the result of the test. So what is important is whatever you are learning in the test, jot it down. You have to make some short notes or do something so that you can revise. If you are forgetting something, then you have to revise it frequently. You can every week you can keep 2 days for revising, that you can do.
Okay, sir.
So that is one way of doing it. So don't worry too much, I mean, because gate is a part of life. Okay, so I mean, so there are many people who are stuck with this gate preparation and all. They are spending 5-6 years for gate preparation. That is not very advisable. So I won't advise anyone to get stuck with gate exam. I mean, this is just a examination. Treat it like an examination. Do not be afraid of it. It's a part of life. So just be calm. Try to do as much as you can. So whatever is in your hand, you can do. You can try your best. After that, what else can you do, right? So you can give your best. What else? What more can you do? You
Yes.
try your best. So what I would suggest is prepare short notes. Okay, do not before the examination you cannot revise the entire notes. Try to make short notes.
Yes, I'm preparing short notes.
Okay, so that you can do. You can make some short notes, and then you can revise it very frequently. If you are forgetting stuff, you revise it frequently and then appear for test. So the more test you give, the more confident you would be, and the more good you can perform. So
Okay,
don't
sir.
be so much. So I'm suggesting you not to be emotional with any kind of exam, be it UPSC, be it GATE, be it any other examination that you appear for in your life. Don't get too emotional with this, with this kind of with any examination, because you see the emotion comes because certain idea has been fed to your mind. So these coaching institutes, there are several coaching institutes which would glorify you if you get a good rank, and you start thinking that this is the only goal that a person can have. That is not so. There are several people who I mean who may not be good at clearing all these great exams, and then they do wonderful in their life. So don't be worried about all this stuff.
No, sir, that's not the reason. I just want to pursue my MTech in a good institute. I just wanted to learn. I just want this institute and that kind of institute. That's why I'm too much like invested in this exam.
Don't worry, just just as I told, just follow that. I think that would be helpful. If you're forgetting stuff, what you can do is, see, every week you would be revising over here itself, because every week if I am giving 4 questions to solve, that will revive some of your concepts. So if you do that, then once revise by practicing sums itself, it doesn't matter whether you were able to do the sum or not. What is important is whatever you have learned from this sum, whether this sum has given you some information that you have learned new, that you jot down somewhere, you write it down somewhere, you revise it, and you then practice it. So don't worry about all those stuff. You'll do good, don't worry.
Okay, sir. Thank you.
So anybody else who has anything to say, or anything to any suggestions that they want to give? So the problem is I do not have an iPad and all those stuff. So I am just showing you from NPTEL from this PPT only. So I'm sorry for that, but it is not possible for me to buy the iPad as of now for financial reasons. Maybe later I will be buying, maybe few months later.
So
Thank
this
you.
is the best session.
Yeah, thank you. Then we will be meeting again on Friday. Okay.
Thank you,
Goodbye.
sir.
Yeah, goodbye. Enjoy yourself. Okay, thank you.
Thank you, sir.
Thank you.
Thank you, sir.